Namaste. Today we will learn exercise 2.1. Before we learned how to read a graph of polynomials and to find their zeros. Zero of a polynomial from the graph is the straight line or the parabola or curve passing through the x-axis. That point is called zero of the polynomial. Now in exercise 2.1 there are 6 graphs given and we have to find number of zeros in each polynomial. You can check the first figure. In that there is no point passing through x-axis. So in that figure there is no zero. Now second figure, there is one point passing through x-axis and in that figure we get there is 1 0. Now in third, there are 3 points passing through x-axis. So we can say there are 3 zeros in the third figure. Now in fourth figure, we can see 2 points passing through x-axis. So it has 2 zeros. Now in fifth figure, there are 4 points passing through x-axis. So we get 4 zeros from that graph. Now at the last one, we can see there are 3 points passing through x-axis. So we can say there are 3 zeros in that figure. So this is how we read a graph to find zeros of polynomial. Now next topic is relationship between zeros and coefficient of polynomials. Before that, I will tell you something about the powers of polynomial. In the case of powers, it should always be a whole number. That is, we can have values from 0, 1, 2, 3, etc. in power. But the power must not be negative value, fraction, or irrational number, that is roots. I will show you. We can have polynomial x raised to 0 or 6x raised to 0. This is a polynomial because the power is 0. It is in whole number. Now, in the case of this polynomial, we can't say this is a polynomial because here in the power there is a fraction. Now this is also not a polynomial because in the power there is a negative value. Next example. This is also not a polynomial because in the power there is an irrational number. So for a polynomial, the thing is that power should always be a whole number. Now what about this? This is not a polynomial because this means 3x square plus 6 into 1 by x. That is here written as 6 by x. Now 1 by x means x raised to negative 1. So here 1 by x becomes 3x square plus 6x raised to negative 1 and in the power you will get negative value. So it is not a polynomial. Now another case, root x plus 4x square. This is not a polynomial. The reason is root x is equal to x raised to 1 by 2. Here in the power there is a fraction. So this is not a polynomial, this is not a polynomial, this is not a polynomial, this also not a polynomial. Always remember a polynomial's power should be whole number. Now we can move to the relationship between zeros and coefficient of a polynomial. To check the relationship between zeros and coefficient of a polynomial, we can first check from linear polynomial. Here 0 means a value which is substituted for the variable and the answer should be 0, and that substituted value is 0 of the polynomial, and coefficient was the constant terms along with the variables. So let us check from linear polynomial. Let a linear polynomial be 3x plus 5, because general form is ax plus b. Here a is equal to 3, b is equal to 5. Now, what will be the 0 of this polynomial? That is, while we substitute a value for x, the answer should be 0. Let us find p of negative 5 by 3. Now, instead of x, we will write 3 into negative 5 by 3 plus 5. Now, this is first term and this is second term. From first term, it is cancelled. Answer is negative 5 plus 5, which is additive inverse. One is negative and the other is positive. So, the answer will be 0. Yes, this is 0 of this given polynomial, because we got the answer 0 while we substitute this value. And there is a relation between the variable in this polynomial. Here a is 3, b is 5. What about negative b by a, which is equal to negative, here negative is in the formula, negative b is 5 here by a, 3. That was the 0 we got earlier. So, we can conclude that in a linear polynomial, 0 of the polynomial is equal to negative b by a. A is the coefficient of x and b is the constant term, and 0 of the polynomial is negative b by a for a linear polynomial. Now we can consider quadratic polynomial. The general form of a quadratic polynomial is ax square plus bx plus c. Now we can take one polynomial, that is 2x square minus 8x plus 6. This is a quadratic polynomial. Now, here a is equal to 2, b is equal to, in the general form it is plus b. So, here b is negative 8, c is equal to 6. You want to take the sign along with the constants here. If it was minus 2, then a should be minus 2. Here it is minus 8, then b is minus 8, like that. Now, we want to first factorize this quadratic polynomial. Factorization we have already studied in the 9th standard. I will show you once more. 2x square minus 8x plus c. We want to factorize this, that is to find factors of a polynomial. For that, first we want to multiply the a term and the c term, that is a and c. A into c. The answer is 2 into 6, which is equal to 12. After finding the product of a and c, then we have to find the pair of factors. 12, we will get how many pairs? 1 into 12 is 12. Next is 2 into 6 is 12. 3 into 4 is also 12. Now from these pairs, we want to take one pair. But the condition is, from that pair, after doing addition or subtraction, with negative or positive of that pair, we want to get the middle term. Now the middle term coefficient is negative 8. This one. That is b is negative 8. Now look, 1 and 12. After doing subtraction or addition of -1, -12 or +1 or +12, there is no chance of getting -8. So this is not the pair. Now what about 4 and 3? After adding or subtracting -3, -4, +4 or +3, we will never get answer -8. So this is not the pair. Now let us check the last one. 2 and 6. Yes, we can get the answer or the result as 8. But how? We want to get -8. For that, we will take -2 and -6. Then we can add them. -2 plus -6 is equal to -8. So this is the pair. We are considering 2 and 6, but here we need -8. For that, we are taking it as -2 and -6. Now how will you split this? This first term is written like this, 2x square. Now the middle term we are splitting. This is the middle term splitting method, and we are splitting it to -2 and -6. This 8 is splitting to -2 and -6. Then how will you write? -8x becomes -6x minus 2x plus 6. Now, from these two terms, this is first two terms, from these two terms you want to find common factor. Here there is 2 and 6. Those are multiples of 2, so we can take 2 as a common factor. So taking 2 outside. Also, in the first term there is x square, and second term 1x is there. Again, x is common factor in this term and this term. Taking that x outside, from 2x square, 2x is taken outside, balance is 1x. That is 2x into x, 2x square. Now this minus here, from 6x, 2x is taken outside. That is 1x is taken outside. So here they will be not having an x, but from 6, 2 is taken, balance is 3. That is 2 into 3, 6, this x. Now, next you want to write this x minus 3 here. This bracket should be written here. I will tell why we are doing so. Now check. Dash into x, you want to get the third term. This was first two terms, from that we take common factor outside, then we get a factor here in the bracket. We are writing it again here. Now check, dash into x is equal to minus 2x. What will you do? Minus 2 into x, then only you will get minus 2x. Now we can check this with 3 also. Minus 2 into minus 3 plus 6. Now this is first term and this is second term. Here you can see the brackets common. To get these brackets common, we are first writing x minus 3 in this step. Then we can say in the next step, x minus 3 factor is common. Now from this x minus 3 is taken outside, balance is 2x. From this x minus 3 is taken, balance is minus 2. Now we got two factors here. We can equate them to 0. X minus 3 is equal to 0. Then x is equal to negative 3 going to RHS, it becomes positive 3. Here 2x minus 2 is 0. Then 2x is equal to negative 2 going to RHS, it becomes positive 2. Here it is product, that is in numerator. So x is equal to 2. This 2 going to RHS becomes by 2. From numerator it goes to denominator. 2 by 2 is 1. So we got 2 zeros here. These were factors. From that we got 2 zeros of this polynomial. That is x is equal to 3 and x is equal to 1. These are 2 zeros. Now let us name them generally alpha and beta. The 2 zeros One is alpha and one is beta. Now, alpha is equal to first 0, 3 and beta is equal to 1. Now, let us check the sum of zeros. That is alpha plus beta. It is the sum of zeros. The answer is 3 plus 1, which is equal to 4. Now, let us consider negative b by a from this polynomial. We want to check negative b by a is equal to, negative is there in the formula. Now b was another negative 8. So b is another negative 8 by a is 2. Negative into negative 8 or negative of negative 8. These two negatives becomes positive. So it becomes 8 by 2. 8 by 2 is 4. Here we can see that sum of the zeros is equal to negative b by a in a quadratic polynomial. Sum of the zeros is equal to negative b by a in the case of quadratic polynomial. Next, let us check product of zeros. That is alpha into beta. 3 into 1 is equal to 3. Now we can check any relation between coefficients. Let us find c by a. C is here 6 by a is 2. 6 by 2 is equal to 3. Yes. That is product of two zeros is equal to c by a in a quadratic polynomial. So first we split middle terms and we factorize the given polynomial. We got two factors, then we equate it to 0 and find the zeros here. Then we got two zeros, we name it as alpha and beta, and we find alpha plus beta, that is sum of the zeros, and we found that it is equal to negative b by a. Next, alpha into beta, that is product of zeros, and we got it as c by a. And now that is the relationship between zeros and coefficients in a quadratic polynomial. Now we can do some problems based on this. Next is questions from exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and coefficients. First one is x square minus 2x minus 8. P of x is equal to x square minus 2x minus 8. First we want to check whether this is in the descending order, that is powers descending order. Yes, it is powers descending order. If it is not, first we want to rewrite it as the descending order. So we can do the problem here. Here a is equal to, simply what x square means, that is 1x square. So a is equal to 1 here. B equal to, take along with the sign, minus 2. C is equal to, again take along with the sign, that is minus 8. Now first we want to factorize it by middle term splitting method. For that we will find the answer of a into c, that is 1 into negative 8. The answer is negative 8. Now we can consider the number 8 without the sign, and we want to find the pairs of factors, that is 1 into 8 is 8. Now 2 into 4 is 8. From these two pairs we want to get the middle term, that is here minus 2. How will you get the minus 2? After doing anything with 1 and 8, you will never get minus 2. Now the next thing is 2 and 4. That there is a possibility of getting minus 2. How will you get? 2 plus minus 4. Let us check. Yes, it is minus 2 because opposite signs addition, then smaller number is subtracted from greater number and put the sign of greater number. So it is minus 2. So how will you write the pairs? X square this is splitted to plus 2x and minus 4x. Now take down this minus 8 here. So this is splitted to plus 2x and minus 4x. Now next step is to consider the first two terms and take the common factor. Here x square and 2x. Common factor is x. Taking x outside, here one x is remaining, plus from 2x, x is taken outside. So here there will be only 2. Now remember, first you want to write this bracket here, x plus 2. Now check it with the previous step, that is dash into x, you want to get minus 4x. What is the answer? Minus 4. Minus 4 into x, minus 4x. Minus 4 into 2, minus 8. That is dash into x, you want to get the third term in the previous step. That is 1, 2, 3. This is the third term. You want to get the third term as this product. So here we don't know first what was the value. Then we check what into x gives minus 4x and you got minus 4. So you can check it with the last term also. Minus 4 into 2, negative 8. Now you want to consider these two terms and you can find this bracket, that is x plus 2 is common in these two steps. X plus 2 is taken here. Here x plus 2 taken, so balances x. Here x plus 2 taken, balances negative 4. Now we got two factors. Now stop there. Now equate each factor to 0. That is x plus 2 equal to 0. X minus 4 equal to 0. Here x is equal to plus 2 going to RHS, it becomes negative 2. X is here, minus 4 going to RHS becomes positive 4. So we got alpha is equal to negative 2, that is 1, 0 is negative 2 and beta is equal to 4. Now let us verify the relationship. That is, first we can find sum of zeros, that is alpha plus beta is equal to negative 2 plus 4. Again opposite signs addition. Smaller number is subtracted from greater number and put the sign of greater number. So you get 2 as the answer. Let us check whether it is equal to negative b by a. Negative b by a is equal to this negative. What was the b? B itself has another negative. So negative 2 by a is 1. Negative of negative 2. Negative into negative. These two negatives becomes positive 2. Yes, it is verified. Now what about the product of zeros? Alpha into beta. Negative 2 into 4 is equal to negative into positive. The answer will be negative 2 into 4, 8. Now we can find C by A. C is negative 8 by A is 1. Negative 8 by 1 is negative 8. Hence, this is also verified. That is, alpha plus beta is equal to negative b by a. Alpha into beta is equal to c by a. We can do the next problem. Next polynomial is, it is in variable s. So, we can write p of s is equal to 4s square minus 4s plus 1. Now here first you want to write a is equal to 4, b is equal to negative 4 and c is equal to 1. Now write it down once more. Now find a into c, that is 4 into 1 is equal to 4. Now find the factors of 4, that is 1 into 4 is 4 and 2 into 2 is 4. Now consider the b term, that is negative 4 here. While you do any subtraction or addition with 1 and 4, you will never get negative 4. If you do with 1 and 4, either you will get 3 or will get 5, but never 4. So, you can take this pair because 2 and 2 operations will get the result as 4. But how will you get negative 4? Negative 2 plus negative 2 is negative 4. Now, this is the way you want to split. That is 4s square, first term. Now, middle term is splitting to negative 2s plus negative 2s. Now, carry down this plus 1. Now, next is from first two terms, you want to take the common factor. What is the common factor here? In 4 and 2, 2 is the common factor. Take 2 outside. In s square and s, 1s is the common factor. So take 2s outside. Here from 4s square, 2s is taken outside. Balance will be 2s. Because 2 into 2, 4, s into s, s square. Minus, from 2s, 2s is taken outside. Balance will be 1. Now next, write this bracket first. 2s minus 1. Now, dash into 2s, you want to get the third term. That is negative 2s. Negative 1 into 2s, then only you will get negative 2s. So, let us check here. Negative 1 into negative 1, positive 1. Now, from these, this bracket 2s minus 1 is common. Balance from this 2s minus 1 is taken. So, balance is 2s. Here also 2s minus 1 is taken. Balance is minus 1. Now, equate each to 0. That is 2s minus 1 equal to 0. 2s minus 1 equal to 0. 2s is equal to positive 1. Here also 2s is equal to positive 1. S is equal to 1. This numerator 2 going to RHS becomes 2 in denominator. That is 1 by 2. Here also S is equal to 1 by 2. So alpha is equal to 1 by 2. Beta is equal to 1 by 2. Let us check relationship alpha plus beta. That is 1 by 2 plus 1 by 2 is equal to. Now I will tell you something else, that is addition of or subtraction of fractions. While you are adding or subtracting fractions, you want to check the denominators first. If denominators are same, then you can simply add the numerators or simply subtract the numerators. But if it is not same, if denominators are not same, you can't do the operations there. First, you want to make the denominator same, equal. Here it is already equal, so no problem. That is 1 plus 1 is 2. Now, don't add the denominators. Just write down the denominator, same denominator. And 2 by 2 is 1. Always remember, in addition or subtraction, never add the denominator. But make it as same denominators. Then only you can do the operations on the numerator. Now, let us check minus b by a. That is negative. B is again negative 4 by 4. Negative of negative 4 means positive 4 by 4. And the answer is 1. Now, verified. Now, alpha into beta. That is 1 by 2 into 1 by 2. Here, there is no need of making denominators same. In multiplication, you can just multiply the numerators and just multiply the denominators. That is 1 into 1, 1 by 2 2s are 4. 1 by 4 is the answer. Let us check it with the C by A. C is 1 here, A is 4. Hence, verified. So, in this relationship of coefficients and 0 is verified. Next polynomial is P of x is equal to 6x square minus 3 minus 7x. Here, it is not in the descending order of powers. First, you want to rearrange it. So, is equal to 6x square. Now, this 7x term is here in the middle. Now, minus 3. Then only you can write the a, b, and C. Now find A into C. That is 6 into negative 3. Answer is negative 18. Now find the pairs of factors of 18. That is 1 into 18, 2 into 9, 3 into 6. From these pairs you want to get the middle term 7. So you will never get from this and this. This is the pair. Now to get negative 7, you want to write it as 2 plus negative 9. The answer is negative 7. So we can split this. That is 6x square minus 7x become plus 2x and plus minus 9x. 7x is 2x plus minus 9x. Now this minus 3. From these two terms, here 2x is common. Taking outside, here you will get 3x plus from 2x, 2x are taken outside, so 1 is here. Now first write 3x plus 1 here. Now check. Dash into 3x, third term in the previous step. What will be the answer? Minus 3. Minus 3 into 3x is minus 9x. Let us check this. Minus 3 into 1, minus 3. Now from these, this bracket is taken common. 3x plus 1. Here it will be 2x and here from this negative 3. Now equate each to 0. 3x plus 1 is equal to 0 and 2x minus 3 equal to 0. Now 3x is equal to plus 1 going to RHS becomes negative 1. X is equal to 3. Here it is product going to denominator then negative 1 by 3. Here 2x is equal to negative 3 going to RHS becomes positive 3 and x is equal to 3. This is going to RHS becomes denominator 3 by 2. So alpha is negative 1 by 3 and beta is 3 by 2. Let us find alpha plus beta. Here I will do it here. Alpha plus beta. That is negative 1 by 3 plus 3 by 2. Before I told you, you can add or subtract numerator when the denominator is different. So first you have to make the denominators same, then only you can add the numerators. For making denominators same, we have two methods, that is one cross multiplication method and one LCM method. If it is small numbers or prime numbers, we can use cross multiplication method. If it is greater numbers or composite numbers, you can use LCM method. Now I will do both the methods here. Cross multiplication means first you want to multiply the numerator of first term into denominator of second term. That is negative 1 into 2. Now write the operation here, that is addition. If it is subtraction, you can write subtraction. Now addition. Next is this numerator into this denominator divided by product of two denominator, that is 3 into 2. Now you will get the answer. Negative 1 into 2, negative 2 plus 3 3s are 9 by 3 2s are 6. And the answer is 9 plus minus 2, that is 7 by 6 is the answer. This is the cross multiplication method to make denominator same. Now the next is LCM method. For that, first method, second method, negative 1 by 3 plus 3 by 2. In this, you want to consider the denominators first. So taking denominators LCM, here 3. 3 is equal to 3 raised to 1 and 2 is equal to 2 raised to 1. Now LCM was product of all, that is each and every factors and their highest power. Here 3 into 2, 3 raised to 1 into 2 raised to 1, the LCM is 6. Now considering this term, here you have denominator 3, but you want to make it as this LCM, that is 6. How will you make it? 3 into 2 is 6. So you will write here into 2. Whatever you do with the denominator, you want to do in the numerator also, then only it will balance. So here you multiply with 2 to make it as 6. So you are doing the same thing in the numerator. Now this is second term. Here 2 is in the denominator. You want to make it as 6. For that you will multiply with 3. As you multiply with 3 in denominator, you want to multiply it with numerator also to balance. Now negative 1 into 2 is negative 2 by, this becomes 6 plus 3 3s are 9 by 3 2s are 6. Now the denominator is same. That is what we do with the LCM to make the denominator equal. Now you can simply add the numerators. Answer is 7 by 6. So this is cross multiplication method and this is the LCM method. You got the answer, alpha plus beta is 7 by 6. That is alpha plus beta is equal to 7 by 6. We want to check it with negative b by a. Is equal to negative of b is negative 7 by a is 6. Negative into negative is positive 7 by 6. Hence verified. Now next is alpha into beta. Alpha is negative 1 by 3 into beta is 3 by 2. In the case of product, that is multiplication, you don't want to make the denominators same. You can simply multiply it. That is numerators and denominators. Minus 1 into 3, negative 3 by 3 2s are 6. Now what about c by a? Is equal to c is here negative 3 by a is 6. This is also verified. Now we can do another problem. Next is a polynomial having two terms, that is first term and second term. P of x is equal to 4u square, then this will be P of u, 4u square plus 8u. Now, if these type of polynomials are given, you want to check whether there is any common factor in first and second term. You will get here 4u as the common factor from first and second term. After taking 4u outside, this you will get u, that is 4u into u is 4u square, plus from 8u 4u is taken outside, then you will get 2, that is 4u into 2 is 8u. Here a is equal to 4, b is equal to 8 and c equal to, there is no c term, so you can write 0, no constant term, that is c is 0. Now here you get 3 factors and you want to equate equal to 0 for each factor, that is 4 equal to 0, u equal to 0 and u plus 2 equal to 0. Now 4 is a constant and constant will never change its value, that is 4 will never be equal to 0. So you can't take this condition. So the remaining ones are u equal to 0 and u plus 2 equal to 0. From this u equal to plus 2 is going this side, so it becomes minus 2. So alpha, that is 1 0 is 0 and beta is negative 2. Now you have to check alpha plus beta, sum of zeros. 0 plus negative 2 is negative 2. Let us check negative b by a, that is negative B is 8 by A is 4. Negative 8 by 4. You get negative 2 because 8 by 4 is 2. Negative. Yes, alpha plus beta and negative B by A are equal. Verified. Next is alpha into beta. That is 0 into beta is negative 2. 0 into any number you get the answer 0. Let us check the C by A. Here C is 0. By A is 4. 0 by 4. 0 by any number, the answer will be 0. But remember, 0 cannot be in the place of denominator. If it is so, then we can write the answer as not defined. But if 0 is in the numerator, then you can write the answer as 0. Hence, verified alpha into beta is equal to C by A. The next polynomial is also having two terms, but here the missing term is middle term. Let us look. P of x is equal to x square minus 3. Here, this is the first term and this is the third term here. That is A is equal to, here x square means 1x square, so A is 1. And we have no bx term here, so B is 0 and C is equal to negative 3, C. Now, if these types of questions are given, first you want to apply the identity A square minus B square. A square minus B square. The identity was A plus B. Expansion is A plus B into A minus B. Now let us consider this as A square and this as B square. Now 3. How will you write in the square form? Simply a number is equal to root of that number into root of that number. That is 3 is equal to root 3 into root 3. That is x is equal to root x square. 3 is equal to root 3 square. So this 3 we can rewrite it as root 3 square. We are not making any change in the equality but just rewriting 3 as root 3 square because root 3 square is 3. We want this in the form A square minus B square. Now A plus B into A minus B is the expansion. This we can write it as A plus B is x plus root 3 into A minus B, that is x minus root 3. Now here we got two factors. Now we can equate it to 0, that is x plus root 3 equal to 0 and x minus root 3 equal to 0. Here x is equal to plus root 3 going to RHS becomes negative root 3 and x is equal to negative root 3 going to RHS become positive root 3. This is the alpha and this is the beta. Let us check alpha plus beta. That is negative root 3 plus root 3. Here this is additive, inverse, same numbers, different signs. Addition, you will get the answer 0. Let us check it with minus b by a. Negative b is 0 by a, 1. 0 by 1 is 0. Hence verified. Now next, alpha into beta. That is negative root 3 into root 3. Root 3 into root 3 is answer 3. Here root 3 into root 3 is 3. Now, negative into positive. One root 3 is negative and the other root 3 was positive. That is negative into positive. Answer should be negative. Now, alpha into beta is negative 3. Let us check C by A. C here is negative 3. By A is 1. Which is equal to negative 3. Hence, verified. So, in these type of polynomials, you want to rewrite it as A square minus B square form. Then you can expand A plus B into A minus B. We will do one more problem like this. square minus 15. Again, we can rewrite it as x square minus root 15 square. Now, this is in the form a square minus b square. Then we will expand it as x plus root 15 into x minus root 15. Now, write each factor equal to 0, that is x plus root 15 equal to 0 and x minus root 15 equal to 0. Here x is equal to root 15 going to RHS become negative root 15. Here x is equal to again negative root 15 becomes positive root 15. This was the question polynomial. Here a is equal to 1, b we have no b term so 0 and c is negative 15. Let us check. This is alpha and this is beta. Alpha plus beta is equal to negative root 15 plus root 15. The answer is 0 because same number with opposite signs. Let us check. Negative b by a, negative of 0 by a is 1 again, so 0, verified. Next is alpha into beta, that is negative root 15 into root 15. Negative into positive, the answer is negative. Root 15 into root 15, it becomes 15. Now, c by a. C by a. C is negative negative 15 by a. A is 1 is equal to negative 15. Hence, verified. So, alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a in quadratic polynomials. Now, these are the relationship between zeros and coefficients of polynomials. Let us check. Considering linear polynomial, the general form is ax plus b. In that we will have only one zero, maximum one zero. That zero is alpha and it is negative b by a. Now in quadratic polynomial, general form is ax square plus bx plus c. We have maximum two zeros and from that zeros, that is alpha and beta, sum of the zeros is negative b by a and product of 0 is c by a. Now next is cubic polynomial. General form is ax cube plus bx square plus cx plus d and we will get maximum 3 zeros in cubic polynomial and let us name it as in general alpha, beta and gamma. Then sum of the zeros, that is alpha plus beta plus gamma is equal to negative b by a. Now again taking two zeros at a time and adding, that is alpha beta plus beta gamma plus gamma alpha. The answer is c by a. Now product of zeros, alpha into beta into gamma is equal to negative d by a. This is not in the point of examination, so you don't want to solve problems from this part, just for your information. But this you have to solve problems and learn. Now we will go to next type of questions. In next type, sum and product of zeros are given. From that, we want to find a polynomial. First question. Sum is, that is alpha plus beta is 1 by 4 and product of zeros, alpha into beta is negative 1. Now alpha plus beta we know that is negative b by a is equal to 1 by 4. Alpha into beta is c by a is equal to negative 1. From this we can say negative b equal to 1. If negative b equal to 1, then positive b is equal to negative 1. How? To change this negative sign, you want to multiply whole with a negative. Then negative into negative b, positive b, negative into 1, negative 1. That is simply, if negative b is 1, then b is negative 1. This is the This is the method I have did here, that is whole into negative. So B is negative 1, A is equal to 4. Now from this C by A we have got here 4. So C by 4 equal to negative 1. C is equal to 4 is going to this side. Then it will goes to numerator, that is negative 1 into 4. C is negative 4. How will you write ax square plus bx plus c? A is 4. 4x square plus b is negative 1x plus c is negative 4. This is the polynomial with sum of zeros 1 by 4 and product of zeros negative 1. Let us do another example. Sum of zeros is root 2 and product of zeros is equal to 1 by 3. Now, sum of 0 means minus b by a is equal to root 2. Alpha into beta, that is product of 0, c by a is equal to 1 by 3. Here first we can consider this part because we get c and a from here. Now c equal to 1, a equal to 3. Here negative b by a is 3 is equal to root 2. Now negative b is equal to, taking this 3 to this side, it becomes 3 into root 2. 3 into root 2 is 3 root 2. Negative b is equal to 3 root 2. Then b is equal to, that is whole into negative. We want to cancel this negative, so we are multiplying with whole into negative. B is equal to negative 3 root 2. Now how will you write? Ax square, that is 3x square plus minus 3 root 2x plus c 1. This is a polynomial. Okay. Sum is 0. That is alpha plus beta is 0. Product is root 5. Alpha into beta is root 5. That is negative b by a equal to 0 and c by a is equal to root 5. How will you write? Let us keep it here. Consider this one. Root 5 means root 5 by 1. So let us take c equal to root 5, a equal to 1. Now substituting the value of a, that is negative b by 1 equal to 0. Negative b is equal to 0 into 1 is 0. B is 0. So how will you write the polynomial? Ax square plus bx plus c, 1x square plus 0x plus root 5. Here 0 into x, it becomes 0. So the polynomial is x square plus root 5. This is the polynomial. Now next, sum of the zeros is 1 and product of the zeros also 1. So negative b by a is 1. C by a is also 1. 1 means 1 by 1. Now from this, we can consider this first. That is here c equal to 1 and a equal to 1. Now negative b by a equal to, sorry, here it becomes 1 equal to 1. That is negative b equal to 1. Then what about positive b? It becomes negative 1. That is whole into negative. So ax square, it becomes 1x square plus bx minus 1x plus c 1. This is the polynomial. Now next, alpha plus beta is negative 1 by 4. Alpha into beta is 1 by 4. That is sum of the zero is negative 1 by 4 and product of the zeros is 1 by 4. So negative b by a, negative 1 by 4 and c by a, 1 by 4. Here let us consider this. C equal to 1, a equal to 4. Now here negative b by a is 4 is equal to negative 1 by 4. Now taking this 4 to the side, it becomes negative b is equal to negative 4 by 4. That is 4 divided by 4 is 1. That is negative b equal to negative 1. Now we want to cancel this negative. So whole into negative. It becomes negative. This becomes positive and this is also positive. That is negative into negative 1, positive 1. Now writing in the form quadratic polynomial, that is ax square, 4x square plus bx, b is 1, 1x plus c, 1. This is the polynomial. Now next, alpha plus beta, that is sum of the 0, 4 and alpha into beta 1. Negative b by a is 4 and c by a is 1. 4 means 4 by 1, c by a means c by 1 by 1. Now take this, c equal to 1 and a equal to 1. Here minus b by a means 1, minus b by 1 is equal to 4. That is 1. Now taking this 1 to the side, negative b equal to 4. 1 into 4 is 4. Negative b is equal to 4, then whole into negative, you will get b equal to negative 4. So how will you write the quadratic polynomial? Ax square, that is 1x square plus bx, b here is negative 4, negative 4x plus c, that is 1. This is the polynomial. Now these were the problems based on zeros and their relationship between coefficient of quadratic polynomial. Now we will do the division of polynomials.